We present a user study investigating the benefits of graphical cues and pre-cues in AR for a manual movement and rotation task. The task consists of a series of subtasks, each of which involves multiple steps. Moving an empty hand to a designated target item, picking it up, moving it to a specific destination while rotating it, and then putting it down. A cue indicates the current step to perform, while pre-cues provide information about future steps before the user performs them. Previous work has shown that pre-cues can be helpful in simple path-following tasks. We extend this line of research by exploring how pre-cues can be applied to heterogeneous tasks that involve picking up, moving and rotating, and putting down objects rather than simply following a path. We investigate how many and what kind of pre-cues will be helpful, as well as how to pre-cue rotations. At the start of a subtask, a yellow line cue guides the user's unloaded hand to the designated object. A cyan line connects that object to its destination to cue its movement, while a wedge set cues the object's rotation. A wedge set consists of two wedges, a green wedge that shows the object's current orientation and a gray wedge that shows the target orientation. We designed the wedge set visualization for rotation based on feedback from pilot studies, while we chose the line visualization for movement based on previous work supported by our pilot studies. We use the same kinds of visualizations for pre-queuing information about future subtasks as for queuing information about the current subtask. However, we do not show the yellow lines for future subtasks because our pilot studies indicated that they didn't provide any additional benefit. Here we show an example of a queued subtask and two pre-queued subtasks that follow it. The line and wedge set visualizations get successively darker and thinner for later subtasks. After the current object is moved to its destination location and orientation, its cyan line and wedge set disappear. All other lines and wedge sets brighten and get thicker and darker proportionally. A yellow line that connects the user's hand and the object of the new current subtask appears, and a line and a wedge set for the next subtask in the sequence are added. This process repeats until the user finishes the task. We conducted two formal user studies. Study 1 explored how different wedge set configurations and the number of lines and wedge sets affect participants' task completion time and subjective questionnaire responses. In the first part of the study, we tested three configurations for wedge sets. In the object-object configuration, both the green wedge and the gray wedge appear on the object. In the object destination configuration, the green wedge appears on the object while the gray wedge appears at the destination. In the destination-destination configuration, both wedges appear at the destination. We found that participants performed best with the object destination configuration, that is, with the rotation visualization split across two places. In the second part of Study 1, we tried to determine the best number of cyan lines and wedge sets. We tested 16 conditions, 1 to 4 cyan lines with 1 to 4 wedge sets. We found that participants performed best with 2 cyan lines and 1 wedge set, or 1 cyan line and 2 wedge sets. To understand the role of the second wedge set when only 1 cyan line was used, we conducted a follow-up study, Study 2. We compared conditions in which the second wedge set had correct rotation information with ones in which the second wedge set had no rotation information and did not find a statistically significant difference in performance. In addition, 7 of the 8 participants indicated in the questionnaire and exit interview that they did not notice when the second wedge set did not show correct rotation information. This implies that participants use the movement information indicated by the places of the second wedge set rather than its rotation information. Thus, it appears that participants perform best when given the movement information of 2 subtasks, that is, 4 places, and the rotation information of 1 subtask. To learn more, please see our paper.